So you are having these 3. Now, option A says that neutralization with sodium hydroxide followed by filtration. Option B, neutralization with sodium hydroxide followed by distillation. Option C, fractional distillation. Option D, filtration followed by distillation. So if you look at this very well, you discover that the option A says that you have what? A neutralization with sodium hydroxide. So which one of them do you want to neutralize with sodium hydroxide? If you neutralize this one with sodium hydroxide, automatically you are going to, what do you stand to gain introducing sodium hydroxide into this? So sodium hydroxide has no significance here, because here when sodium hydroxide is introduced, it can react with this. When you have acid-base reaction, you have salt and water formation. So are you interested in getting salt? But since the question asks us that how can we separate this? This one is insoluble. This one is insoluble. So what you need to do now is to subject it to what? Filtration. By the time you subject this product to what? Filtration. Filtration. So sand will be removed. When you now subject it, so you have sand removed. So you now have what left? Methanoic acid and water. Now look at what is the boiling point of water. You see approximately 100 degrees Celsius. What is the boiling point of methanol? 101 degrees Celsius. So you have what? Close boiling point. And you are talking about what? 2 liquids, 2 miscible liquids with what? Close boiling point. So which method separates on the basis of closeness in boiling point? It is no other method than what? Distillation. Because you have close in boiling point, it is distillation. So when you subject this to distillation, then you have this one removed, water removed, then followed by this. So that is the way. So the answer will definitely be option D, which says that filtration followed by distillation. This is a technical question, and it's also what? UTME question. Question number 10. The presence of an impurity in a substance will cause the melting point to, this is another repeated question. You can see how they repeat questions. They have exhausted the questions in their question bank. So they keep repeating questions. That is why it is very pertinent to study all these questions very well, and I can bet it with you that come the exam, you will definitely come out in flying colors, because most of their questions are repeated. So the most important thing is to get the basics. Once you are able to get the fundamental, then you see that the answers come out to you naturally. So it is very pertinent that you need to understand this question by virtue of my explanation, digest it, and I can bet it with you that your success will definitely be your turning point. So take note of that, and let's see some other questions also. Question number 11. A mixture is different from a compound in that the properties of a compound are those of its individual constituent. No, the properties of a mixture differ from, because what that one is saying is that if you have sodium chloride is definitely coming from what? Sodium and chlorine. So you have this. So this one is not saying the properties of the property of a compound differ from what? Its individual constituents. So how come option B, the properties of a compound are those of its individual? That is wrong, because the properties of this is different from the property of this and this. So that option B can never be the answer. The only option that will be suitable here is option D, which says that, which states that the constituents of a compound are chemically bound. Yes, they are chemically bound. They are chemically bound, and while those of a mixture are not. So the answer here is D. Answer to question number 11 is D. Question 12, that's question number 12. The separation of mixtures based on the principle of solubility of a solid in two miscible liquids is A. Fractional distillation, B. Distillation, C. Precipitation, D. Filtration. If you look at fractional distillation, it is used to separate two or more substances with respect to what? To their boiling point. So it has no significance here. Then distillation is also the same principle. It is used to recover solvents from a solution. So the option C says that precipitation. So you talk about precipitation. Why the D is filtration. So in precipitation, I explained by using iron 2-6. You have your ethanol, then you have your water. I said that this one is miscible with this one is also miscible with this, but this one is immiscible with this. So if you want to separate this one from this mixture, all you just need to do is to introduce what? Ethanol. So ethanol, if you want to separate solid into miscible liquid, you use what? Precipitation. So the option to question 12 is definitely going to be option C. That is precipitation. Chemical combination, that is the second topic, which under this topic, candidates should be able to 1. Perform basic calculations involving formulae, equations, chemical composition, and the mole concept. 2. Deduce the chemical laws from given expression or statements. Then 3. Interpret data based on these laws. 4. Interpret graphical representation based on these laws. These laws include law of conservation of matter, which says that matter can neither be created nor destroyed during a chemical reaction, but can be converted from one form to another. Then law of definite proportion. Law of definite proportion, from your previous lesson, you ought to have learned that it is also known as law of constant composition, which states that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. So what it means is that if you have, let's say, copper 2 chloride, copper 2 chloride will definitely be coming from what? Copper solid. You have this solid plus O2. So it's saying that, it's stating that all pure samples of a particular chemical compound contain similar elements combined in the same proportion by mass. That is what law of constant composition or law of definite proportion is talking about. Then law of multiple proportion, it states that when there are a mixture of two substances or elements A and B which do not react chemically together, the various masses of a particular element will react with a fixed mass of the other elements are in simple multiple ratio. That is what that one is stating. So in that situation, a typical example of that is, before you can have copper 2 oxide, then it must definitely be coming from copper and what? Oxygen. So you have this. So you see that when you have two substances, the various masses of this that are combined with separately with the fixed mass of this are in simple multiple ratio. You also have law of reciprocal proportion. The difference between that is you can have A, B, and C coming together to combine with D. So the difference between law of multiple proportion and law of reciprocal proportion is that this one you have A combining with B, but this you have ABC combining with D and in reciprocal proportion. So take note of that. Then let's talk about relative atomic mass, the one they call RAM. RAM and RMM. So this one is relative atomic mass, this one is relative molecular mass. What's relative atomic mass? The relative atomic mass is the number of times the average mass of one atom of an element is heavier than 1/12 one atom of carbon-12. That is what relative atomic mass is talking about. But when you talk about relative molecular mass, is the number of times the average mass of one molecule of an element is heavier than 1/12 the mass of one atom of carbon-12. So the major difference between relative atomic mass and relative molecular mass is that this one is talking about atom, while this one is talking about what? Molecule. So take note of that. So then let's talk about laws, especially the gas laws that we have. We have Boyle's law. Boyle's law is the first one. Boyle's law. So this one states that the volume of a given amount of gas is inversely proportional to pressure, provided the temperature remains constant. That's why you normally have PV is constant, where you now have P1, V1 equals to P2, V2. So in this situation, you have the pressure of the volume of a given mass of the gas is inversely proportional to the pressure, and you resulted to this formula. So also we should know at this point that 1 atm is equal to 760 millimeter mercury, which is equal to 101,325 Newton per meter square. So that is the relation. It now depends on what you are working with. If you are working with ATM, you know this. If you are working with millimeter mercury, you know this. If you are working with Newton